So for this lesson, you are going to be writing these notes directly in your notebook on page 29. So we're going to learn how to simplify radicals. So square root of 32, when you put that in your calculator, you get approximately 5.66. But what we're going to learn how to do is how to break down this radical into a more simple form rather than having a decimal like this. Okay, so here's what you do. So first of all, you do need to know your perfect squares. So the perfect squares, at least you should know the first 12. I'm going to write them off to the side. It's going to be 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. So these are perfect squares. And what makes them perfect squares is I could take the square root of it and it would equal a whole number. So for instance, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, etc. So these numbers are going to help us simplify these radicals. So here's what we do. To simplify a radical, what we're going to do is we're first going to find a perfect square factor and then we're going to rewrite it. So for instance, one of these numbers goes into 32 and 16 goes into 32. So I could rewrite square root of 32 as the square root of 16 times the square root of 2, since 16 times 2 is 32. Then what we do is one of these is always going to be a perfect square. So since 16 is a perfect square, we're now going to simplify the perfect square. Square root of 16 is 4, and then square root of 2 can't be simplified, so we leave it as square root of 2. So that's how you simplify a radical. So again, what we do is we find a perfect square factor of the number under the radical. So in this case, it's 16. 32 can be written as 16 times 2, and then we simplify the perfect square. Square root of 16 is 4, and square root of 2 can't be simplified, so we leave it as square root of 2. So this mathematically is really 4 times the square root of 2, and it's going to equal the same thing as the square root of 32. So if you put this in your calculator, you're going to get about approximately 5.66. All right, so let's look at the second one. So this one is square root of 54. So again, first thing we're going to do is we're going to find a perfect square factor. So in looking at our list here, I know a number that goes into it is 9. 9 times 6 is 54, so I'm going to rewrite this as the square root of 9 times the square root of 6. My perfect square is 9, so I'm going to simplify that. And the square root of 9 is 3. And then square root of 6 can't be simplified, so I'm going to leave it as square root of 6. And then you're done. Okay, looking at the third one, we have square root of 4 times the square root of 72. So for this one, there's a number on the outside, so what we're going to do is we're just going to leave that on the outside. We can't do anything to that. And then 72, a perfect square that goes into 72 is 36. So it's going to be square root of 36, and 36 times 2 is 72, so it's square root of 2. So again, 36 times 2 is 72. That's why we simplify it that way. Okay, then from here, the 4 comes straight down. Square root of 36 is 6. And then square root of 2 can't be simplified, so we leave it as square root of 2. Once we're here, since there's numbers on the outside, what we're going to do is we're going to multiply these. So multiply numbers on the outside. 4 times 6 is 24, so this is going to be 24 times the square root of 2. And that's as simplified as you can get. Okay, these are two problems on the practice. I just want to make sure we know how to do these as well on page the page 30 handout. So we have square root of 44. So again, looking at my list of perfect squares over here, 1, 4, 9, 16. So a perfect square that goes into 44 is going to be 4. So I could rewrite square root of 44 as the square root of 4 times the square root of 11, since 4 times 11 is 44. And then we're going to simplify the perfect squares. So square root of 4 is 2. And then we leave square root of 11. Okay, looking at the second one, we leave 2 on the outside. And then we look at a perfect square that goes into 50 is 25. So it's going to be square root of 25 times the square root of 2, since 2 times 25 is 50. And then we can simplify square root of 25 is 5. So 2 times 5, and then square root of 2 stays the same. And then we multiply these numbers. 2 times 5 is 10. So it's going to be 10 times the square root of 2. All right, the next thing I want to go over is how to multiply radicals. So going back to page 29. Okay, what we do is we first multiply the numbers on the outside, or sorry, on the inside. So I have a 6 and a 10. So what I'm going to do is I'm going to multiply numbers on the inside. So 6 times 10 is 60, so this is square root of 60. And then what we're going to do is we're going to simplify like we did before. So when I say see above, I mean the notes that we just did about how to simplify a radical. So what we're going to do is we're going to look at 60, and we're going to think of what perfect square goes into 60. Well, 4 goes into 60, so we can rewrite 60 as square root of 4 times square root of 15. And I know you might be thinking, well, why can't I write it as 6 times 10? Well, 6 and 10 are not perfect squares, whereas 4 is a perfect square, and that can be simplified. Square root of 4 is 2, and then we would just leave this as a square root of 15. And then you're done. Looking at the second example, so if you notice on this one, I have 2 numbers on the inside, the 2 and the 10, but then I also have my numbers on the outside, the 6 and the negative 2. So what we're going to do is we're going to multiply the inside and the outside. So the numbers on the outside, 6 times negative 2 is negative 12. And then 2 times 10 is 20, so this is going to be the square root of 20. Once you multiply the numbers on the inside and the outside, then we're going to simplify. And again, I'm going to say see above for the notes on how to simplify a radical. Well, we know we can't simplify negative 12, so that comes straight down. A perfect square that goes into 20 is 4, so I can rewrite this as 4 square root of 4 times square root of 5. And then we simplify our radicals. Well, 4 is a perfect square, and the square root of 4 is 2. Okay, and then just like before, when there's numbers on the outside, we multiply them. So negative 12 times 2 is negative 24 times the square root of 5. All right, so now I'm going to go over how to divide radicals. Okay, so there is a rule in math that basically says you can't have radicals in the denominator because it's not considered simplified. So to get rid of the radical, what we need to do is we need to multiply by a big one, and I'll show you what I mean in a second. So we're going to multiply by the big one, okay, which is you just look at the denominator, so whatever radical is in the denominator over itself. So for instance, if we have 1 over the square root of 3, the radical in the denominator is square root of 3, so my big 1 is going to be square root of 3 over square root of 3. So the reason I call that a big 1 is because square root of 3 over square root of 3, that just equals to 1. And remember, whenever you multiply by 1, it doesn't change the value. That's why it's okay to do this. So looking at this example up here, my big 1, well, my radical in the denominator is square root of 5. So I'm going to multiply by square root of 5 over square root of 5. Okay, once you do that, what you're going to do is you're just going to multiply fractions straight across. Okay, because that's how you multiply fractions. So the top, 3 times the square root of 5, you can only multiply if they're either both radicals or both numbers. So since this is underneath the square root, we can't multiply them, so it would just be 3 times the square root of 5. And in the denominator, these are both radicals, so we can multiply 5 times 5 is 25. So this is going to be over the square root of 25. The last step is you're going to simplify the radicals. And if there are fractions, you can simplify those too. Okay, so square root of 25 is 5, so this becomes 3 times the square root of 5 over 5. And since we can't simplify 3 over 5, this is our final answer. Okay, something that you might find helpful, and it might help you kind of skip this step right here, is that when we multiply a radical by itself, so for instance, if I multiply square root of 3 times square root of 3, that's square root of 9, but the square root of 9 is 3. Okay, same thing if I multiply square root of 5 times square root of 5, that's square root of 25, but that simplifies to 5. So essentially what happens is the radical just cancels out. So for instance, if I tell you to multiply square root of 21 times square root of 21, you don't have to multiply 21 times 21. You should know that the radicals just cancel out, and that's just going to equal 21. Okay, that will save you a step here. Okay, so let's look at number 6. We're going to do the same thing here. So I have 6 over the square root of 12. So first thing we're going to do is this step right here is we're going to multiply by our big 1. Since the denominator is square root of 12, we're going to multiply by the square root of 12 over the square root of 12. And then we're going to multiply straight across. So the top becomes 6 times the square root of 12. And the denominator, again, 12 times 12 is 144. But the square root of 144 is 12. So the radicals just cancel out. So that ends up just being 12. Okay, once you're here, then you need to simplify the radicals. Well, we have square root of 12. That can be simplified. So a perfect square that goes into 12 is 4. So I can write this as square root of 4 times square root of 3, since 4 times 3 is 12. And the square root of 4 is 2. So I can simplify the square root of 12 as 2 times the square root of 2. So I'm just going to replace that there. So this becomes 6 times, and then we're going to replace this with the square root of 12. So 2 times the square root, oops, this should be a 3, of 3 over 12. Okay, then we multiply 6 times 2 on top is 12. So this is 12 times the square root of 3 over 12. And the very last thing is you should multiply the fractions on the outside. So 12 over 12 basically turn into 1. So this just ends up being the square root of 3. So this is the most amount of work these problems will be. Most of them will not take this long and this much simplifying. So this would just be the square root of 3. Okay, let's look at 2 more practice problems. So this is again is on the handout. So starting with a 1 on top. So first thing I'm going to do, I see a radical in the denominator. I'm going to multiply by my big 1, which is going to be square root of 3 over square root of 3. And when we multiply straight across, the top becomes 5 times the square root of 3, and the bottom becomes 3. And then we check our radical. We can't simplify square root of 3, so we leave it. And then 5 over 3 can't be simplified, so from here we're done. All right, looking at the second one, we have 3 over the square root of 27. So first thing we're going to do is we're going to multiply by our big 1, which is going to be the square root of 27 over the square root of 27. And we multiply straight across. So the top becomes 3 times the square root of 27. The denominator, we don't need to multiply 27 times 27 because remember when we multiply identical radicals, the radical cancels out. So we end up with just a plain old 27. Okay, next thing we need to do is we need to try and simplify this square root. So a perfect square that goes into 27 is 9. And that's going to be square root of 9 times square root of 3. And the square root of 9 is 3. So square root of 27 simplified is just going to be 3 times the square root of 3. So I'm going to replace that here. So this becomes 3 times 3 times the square root of 3. So again, I'm just replacing this for square root of 27 there. Okay, over 27. Now we're going to multiply. 3 times 3 is 9. Denominator is 27. And then the very last thing we should do is we should simplify here. The top can be divided by 9, and the bottom can be divided by 9. So 9 divided by 9 is 1, so this becomes 1 times the square root of 3, and 27 divided by 9 is 3. So you could also write this as just the square root of 3 over 3. And there it is simplified. Alright, now I'm just going to go over a couple of the practice problems. So looking at number 3. We're just simplifying this radical. So first thing we need to do is we need to figure out the largest, a perfect square that goes into it. So looking at 128, off the top of my head, I don't know. So what I'm going to do is I'm going to get out my calculator. I'm going to do 128, and I'm just going to pick a number. So I'm going to pick 49. So 49 doesn't go into there, so I'm going to pick another number. 128, I'm going to try 36. 36 doesn't go in. 128. Divided by 16 is 8. I think there's a bigger number. I'm going to try 128 divided by 64. 64 goes into it. So I can rewrite the square root of 128 as the square root of 64 times the square root of 2. And I can simplify square root of 64 as 8 times the square root of 2. Okay, the next one I'm going to do is I'm going to do number 11. So first of all, number 11, what I'm going to do is I'm going to multiply my numbers on the outside. So 3 times 5 is 15. And then I'm going to multiply my numbers under the radical. So 2 times 12 is 24. Next thing we do is we look at the radical and we see if we can simplify that. So a perfect square that goes into 24 is 4. So I could rewrite this as 15 times the square root of 4 times the square root of 6. And then we simplify the perfect squares. So this ends up being 15 times 2 times the square root of 6, and then we can multiply these numbers. 15 times 2 is 30. So 30 times the square root of 6. Alright, the last one I'm going to go over is number 16. So this, I see a radical in the denominator, so first thing I need to do is I need to rationalize by multiplying by square root of 5 over the square root of 5. That's my big one. And then we multiply straight across. So in this case, 2 can't be multiplied, but we can multiply the 3 and the 5 since they're both radicals, so that's 15. And then square root of 5 times square root of 5 turns into just 5. And then we look and see if we can simplify our radical. Well, there are no perfect squares that go into 15. So in that case, we can't simplify this any further, and this is actually our final answer. You should also check your numbers on the outside, but 2 over 5 can't be simplified, so we would just leave it like this.